For example 2, it says consider the function f of x equals negative 2 over 2x minus 3. And then part A says state the domain. Part B says state the equation of the vertical asymptote and the horizontal asymptote. Part C asks us to state the x and y intercepts. Part D asks us to describe the behavior of the function near the vertical asymptote. So we'll have to find the vertical asymptote and then figure out what's happening to the function close to it, to the left and to the right of the asymptote. And then describe the end behavior, so seeing what the function is doing at the end of the graph, whether it's approaching the horizontal asymptote from above or from below. And then finally sketch a graph of the function. Okay, so I'm going to do this on a separate sheet of paper. And so the first part I have here, I've written down the function. And the first part asks me to state the domain. So the domain includes all values of x except for any restriction on the denominator. So in this case, the only restriction is 3 over 2. So my domain is x is an element of all real numbers such that x cannot equal 3 over 2. And then the vertical asymptote is x equals 3 over 2. And if you're looking at graphing it, it's about 1.5. The horizontal asymptote, again, would be y equals 0. Okay, so since the denominator is going to become very, very large, depending on what value of x you plug in, you'd have a horizontal asymptote at y equal to 0. And then for the x-intercept, what we're looking for is when you plug in 0 for y. So if you plug in 0 for y, we're looking for the value of x as a result. And you'll notice that there is no value of x that will give us a value of y equal to 0. So in terms of x-intercepts, there are none. Okay, there are no x-intercepts. Okay, and that makes sense because we have a horizontal asymptote along the x-axis. In terms of the y-intercept, we're looking for f of 0. And if I plug in x equal to 0 into the function, I end up getting negative 2 over negative 3, which means this simplifies to positive 2 over 3. Okay, so the y-intercept is at 0 and 2/3, or 0 and 0.66 roughly. And then we're going to look at the behavior near the vertical asymptote and the behavior at the ends of the graph as well. So I sort of created a little table here, much like the one that we saw in the previous example. And so in terms of the behavior near the vertical asymptote, so we're going to see what happens as we approach 1.5 from the right and 1.5 from the left. And then in terms of end behaviors, we're going to see what happens to the function as we approach positive infinity and negative infinity as well. Okay, so I'm going to choose a value of x that's slightly to the right of 1.5, so something like 1.51. And if I evaluate that on my calculator, if I try to find f of 1.51, I end up getting an answer of about negative 100. Okay, so that tells me at about 1.5, slightly to the right of it, the function is actually decreasing since it's about negative 100. So it's probably approaching negative infinity. Okay, and so if I look at 1.5, slightly to the right of 1.5, it's sort of doing this. It's going downwards. Okay. If I choose a value of x that's slightly to the left of 1.5, so if I choose something like 1.49, and I evaluate f of 1.49, I end up getting an answer of about positive 100. Okay, so what that tells me is slightly to the, oops, I think I did this backwards. I did do it backwards. So if I look at 1.5, slightly to the right of it, it's approaching negative infinity. And slightly to the left of it, it's approaching positive infinity. Okay, so it's sort of doing that on the two ends of the vertical asymptote. So because this number is positive and is quite large, it's probably going to be approaching positive infinity. Okay, and then in terms of end behavior, so we're looking at what happens along y equals 0. So we'll just plug in a very large value of x and a very small value of x. And if we evaluate that, what I end up with for the first one is a very, very small negative number. So that means it's approaching 0 from below. Okay, so what that tells me is as I approach positive infinity, it's approaching 0 from below. So it's going to be down here. And then as I approach the function, as I approach negative infinity for x, the function is actually going to approach 0 from above. So it's a value of the function, or a value of y that's just above 0, but it's positive. So that tells me that the function is going to be approaching the horizontal asymptote from above. Okay, and then we can take all this information and we can use it to help us graph. So the first thing I'm going to graph is a vertical asymptote at 1.5. So I'll use a scale of 1/2. And so I'll sketch the function. So we have a vertical asymptote at 1.5. Remember to draw a dashed line. So there's x equals 1.5. And then I have my horizontal asymptote at y equals 0. And then we had no x-intercept, so we had a y-intercept at 0 and 2/3, so that's about there. And then using the behaviors near the asymptote, so slightly to the left of the vertical asymptote, we had the function approaching positive infinity. And slightly to the left of it, we had it, slightly to the right of it, we had it approaching negative infinity. So just like we saw up here. So approaching positive infinity on the left and approaching negative infinity on the right. And then along the horizontal asymptotes, the end behaviors, it's approaching 0 from above as it approaches negative infinity. There it is. So as I approach negative infinity, it's approaching 0 from above, so it's about here. And then as I approach positive infinity, it's approaching 0 from below, so it would be about here. And so if I sort of join it, you'll see that they actually end up in the right quadrants based on where the asymptotes are. And so the function sort of looks like that. And there is f of x.